Regardless of age, about 20% of Canadian adults participate in fitness activities at least twice a week. However, these fitness activities change as the people get older, and occasionally participants become non-participants as they age. A local survey was applied to N equals to 100 adults over 40 years old in order to understand how many of them participated in a fitness activity at least twice a week. The results are given in a file named Case 2 Activity Levels. So I've got that file right here. Let's make this a little bit easier to see. Okay, so we've got our file. At the top, it's got the heading, participating activities, and we have all 100 people. So let's go back and see what they ask us about this. It says, in Part A, do these data indicate that the participant rate for adults over 40 years of age, that's everybody in the survey, is significantly less than the 20% figure? So looking at our data, a Y indicates a yes. This person or observation in the 6th row here, this is actually the 1, 2, 3, 4, the 5th observation, but it's in the 6th row because we've got this label here, participating activities, taking up the 1st row. This first observation that says Y indicates that that's the first person who said yes, they are participating in activities at least twice a week. Every one of the Y's means that yes, they are. Every one of the no's means no, they're not. And they're asking us, do the yeses or the Y's, are they, what does it say here? They want to know if the number of yeses is significantly less than 20%. So what it is that we're trying to figure out here is this. Is the proportion in the population less than 0.20? Is that what's going on here? Now we're going to solve this using a hypothesis test, and in case 1 I had a look at a hypothesis test and all the different steps. My first step we can take care of pretty quickly here. It's going to be our hypotheses, the null and the alternative. And remember, I mentioned in case 1 that anytime you are dealing with a sign, like a less than or a greater than sign, that cannot be in the null hypothesis. That has to go in the alternative hypothesis. The null hypothesis, instead, has to make use of the equal sign. So these are my hypotheses that I'm testing. The alternative would say, yes, they are significantly less. Significantly less than 20%, and the null hypothesis would say no, it's not significantly less than 20%. Now these comments that I'm putting in here, you do not need these comments. Really all that you need for full marks is to start off with your hypotheses, like we've got them there. Now the next step in a hypothesis test is to make an indication as to what sort of a significance level that you're using. And they didn't mention anything in the wording, so we're going to assume a 5% significance level. Why 5%? Well, that's the basic rule. The convention is it's always 5% unless you're told otherwise. And they didn't mention anything in Part A about whether or not we're supposed to use 5%, 10%, 1%. So if nothing is mentioned, you assume 5%. So that's the next step taken care of. Now after this, I think that they told us we could use either rejection or the p-value method. And so I'm going to start off by going through the rejection region method. So the rejection region method works like this. I'm going to have a distribution where at the center goes my hypothesized value. So that's going to be that the proportion in the population is 20%. But we're checking to see whether or not it's significantly less than 20%. So that's going to put a rejection region in the lower tail. So if my results fall in this lower tail, that will be when I reject the null hypothesis. Now we don't need to draw this picture. all that we need to find is what's called the critical value. And the critical value here is going to be based on alpha, and we know that alpha is 5%. And we've already looked up earlier on that 5% in one tail is equals to 1.645. But keep in mind that this is the negative side, this is the positive side. So this is going to be negative 1.645. So again, you don't have to draw this, but what you do need to do is you need to give them what's called the decision rule. The decision rule tells you when to reject. So we're going to reject the null hypothesis if z is less than negative 1.645. So that is the next thing that I would need 4 marks to answer this question properly. So I've got my hypotheses, I've got my significance level, I've got my rejection region. Everything else that's on the outside here is just extra descriptions that I'm giving you to help you to understand what it is that's going on here. Now what comes after this is my test statistic. And our formula for this, when we're dealing with proportions, the test statistic looks like this. It's p hat, that's the sample proportion, minus p, that's the hypothesized proportion, which we know is 0.20, over p times 1 minus p, again, hypothesized, over n. Now some of these we know. For example, like I said, this is 0.20. We know that n, our sample size, is 100, but what we don't know is p hat. That's the sample proportion. And the sample proportion is equals to x over n, where n is the sample size and x is the number of successes. What does that mean? Well, the number of successes is simply just the number of yeses. How many people said yes, they are participating. So that's what we have to get from Excel. We simply need to get a count of how many people out of the 100 said yes. And there's a few different ways of doing that. I prefer to stick with methods that work for any version of Excel. So what I'm going to do is this. I'm going to go down to the very end. I don't trust just counting the y's. You could do that. You could just count 1, 2, 3 and keep going. But there's always the chance then that you might miss something. So instead, I'm going to go down to the bottom of my data, pick the first empty cell, and I'm going to type in the following. This formula should work in any version of Excel. Equals, then the word count, because I want Excel to do the counting for me. I'm going to open up some brackets, and, oh, actually, sorry, it's not just count, it's going to be count if. I only want Excel to count if it's a certain type of thing, if it's a Y. Okay, so how do I do that? Well, I need to tell Excel where to start. And considering that we are in column A, and I want it to begin in row 2, not row 1, because row 1 was where the label was. I want it to start there, and I want it to finish right above here in 1, 0, 1. Now you can see there's a little hint underneath as to how to handle this. So I've given the range. This is where to start and where to finish. That's how my range goes. Then I put a comma, and I tell it what criteria I want it to follow. So I'm going to put in quotes here a Y. I think it's quotes, double quotes, that I need to do like this. If not, it's just going to be single quotes. So let's try this out. I'm going to close the bracket and hit enter. Good. So it did things properly. It's counted 15. So there are 15 successes. There are 15 Ys. That's one way to do this. There is another way to do this. Well, like I said earlier, you could literally just count the Ys yourself. But there is another way we could do this. So in order to do that, I'm going to delete this. We don't really need this. I'm sure we're going to be able to remember that this said 15. I'm going to go back up to the top. I think I'm going to go back up to the top. Okay, let's just scroll all the way up. Okay, another way to do this would be to sort my actual data. Now, I can do that by highlighting all of my values and then selecting data at the top and sorting it. I'm going to sort it by column A, and what it does is it puts all the no's together, and if I keep scrolling down, eventually it's going to put all the yeses together, and then I can count them a lot more easily. I can determine that there are 15 of these. See, even when I just highlight them, it tells me, you can see down here in this corner, it says 15 rows by 1 column. So it again confirms that I have 15 yeses. Okay, so let's go back and make use of that information. So I'm going to get my sample proportion worked out. It is 15 over 100, and that's equals to 0.15. Okay, so now I have everything I need. I've got my hypothesized proportion, my sample size, my sample proportion. So I can fill all that in. It's 0.15 minus 0.20, so the sample proportion minus the hypothesized proportion, over, under the root sign, I've got my hypothesized proportion times 1 minus the hypothesized proportion over the sample size. And so what do we get here? I'm going to calculate this out. So this comes out to be a z-score of negative 1.25. Okay, so you absolutely have to show them all of this, and as well you should be showing them how you worked out your sample proportion. Now what do we do with this? Well, we said we were going to reject the null if z was less than negative 1.645, but this is not less than negative 1.645. So that brings me to my conclusion. I'm going to say do not reject the null hypothesis, because this is not less than negative 1.645. It's not in the rejection region that we defined. What does it mean if I don't reject the null? Well, here's my null hypothesis. I don't reject it. I'm sticking with this idea that it's not significantly less than 20%. So I prefer to use the wording that they give. So I would say, do the data indicate. Actually, let me see if I can copy and actually I'm just going to put my conclusion right here. That's going to be the easiest way to do that. I'm going to say, first of all, do not reject the null hypothesis, and then I would say no. Do these data indicate? I would say that these data do not indicate that the participant rate for adults over 40 years is significantly less than the 20% figure. So you would go all the way to this point, giving them exactly the same wording, and then at the end you must include the significance level that you've used. So you can't put ... like I've done here. I was just running out of room. I'm just saying that you should be working with all of this wording here, all the way up to 20% figure, obviously not with a question mark at the end, because we're making a statement. We're saying no, the data do not indicate that. And then we're going to just add in significance level used as 5%, or you could say that alpha equals to 0.05, or assuming a 5% significance level, something like that. So that would be our conclusion, and that takes care of part A.